All right, so 8b.1, we're going to be now working on something called solving systems of equations, okay? And systems of equations means that there is two or more lines going through the same point, okay? So a system of linear equations, a system of linear equations consists of two or more linear equations. So basically that means you're going to have two or more straight lines, okay? And the solution to a system is the ordered pair that makes both equations true. Okay, the solution to a system is the ordered pair that makes both equations true. So for this first example, okay, it's telling you that, or it's basically asking you, is this the solution to this systems of equations? So what you would see is two equations that are going to look like this, okay, so two different equations, and a solution. It's asking you, is this a solution to this systems of equations? So what you have to do is you're going to take the x, which is 3, and the y, which is 2, and you're going to plug them in. Okay, so you're going to plug in 3 for the x and 2 for the y into this first equation. And if it works, if you get a true solution at the end, that means yes, this is an answer to this first equation. But then you have to check the second equation and do the exact same thing. So wherever there's an x, we're going to plug in a 3. So 2 times 3 plus 4 times, instead of y, we're going to plug in 2. And then we just have to kind of work this out. Okay, so 2 times 3 would give you 6, plus 4 times 2 is 8. Then 6 plus 8 gives you 14. And since 14 is equal to 14, you have to check these. This point is a solution to this equation. So that means basically this point would be on this equation or on this line if we graphed it. Okay, now I'm not asking you to graph it just yet, but this one would be true. Now you have to check the other one. So you do the exact same thing. Wherever there's an x, you're going to plug in a 3. And wherever there's a y, you're going to plug in a 2 and see if this works. So 3 times 10 would give you 30, minus 2 times 2 is 4. And I know a lot of you guys are going to be able to do this in your head, but I do want you to show as much work as you think I would like to see. So make sure you're showing some work. 30 minus 4 gives you 26. Since 26 does equal 26, yes. Okay, so solutions of linear equations. So if you were asking, is this a solution to both of these linear equations, it would be a yes answer. Next thing you're going to do is systems of equations on a graph. Okay, on a graph. On a graph, the solution is the intersection of two lines. Okay, the intersection of two lines. And the solution is written as an ordered pair. So that means x comma y. So it says finding the solution to a systems of equations on a graph. Literally, if I just give you a picture like this, the answer is just where they cross. Okay, so I want to know what point is this right here where they cross. So to figure out that point, you just count over. So remember, we always go left to right first. So over 1, 2, 3, down 1. So if I labeled that point, it would be 3, -1. And that's your solution to the systems. And then the last thing you're going to have to do today is actually solving a systems by graphing. Okay, so if I give you two equations, I'm going to give you two different equations, and if you have two different colors of markers or pens or pencils or anything like that, I would recommend using two different colors, okay? The first one is going to be y equals -1/2 x plus 5. The second equation is going to be y equals 3x minus 2. Okay, so first thing you want to do, step one, is to graph both equations, okay? Then the second thing is basically just find the point of intersection, okay? And there should only be one point of intersection here. So before you can graph, remember things have to be in y equals mx plus b form. If they're not, you have to rearrange it to get it into y equals mx plus b. So remember, y equals mx plus b, okay? Remember when we're graphing, the first thing you're looking for is the b. The b is where you begin, okay? It's your y-intercept, or where you begin. The m is your slope, which we know is, oh, sorry, you can't see that. So the y-intercept is where you begin. The slope is how you move. So I'm going to do two different colors here. So for the red line, my beginning, or my y-intercept, is at 5. So on this y-axis, I'm going to count up 1, 2, 3, 4, 5. Kind of going off, but it'll be okay. Then you're going to move. Remember, we always move whatever's attached to the x. The x is not the slope. It's just tells you how to move. So whatever's attached to the x is how you're going to move. So this tells you I'm going to go down 1, right 2. Like that. Down 1, right 2. And I'm just going to make 3 lines, or 3 dots, so that it helps me make a little bit of a straighter line. Then once you have at least 2, 3 is better, connect them with a line. Then we're going to go to the green one. So same thing here. Your slope is whatever's attached to the x. The m, or the b, the y-intercept is how you're going to begin. So start at down 2, so we go down 2. Then my slope, if it helps you, you can make this into a fraction. So that'd be 3 over 1. So that tells you to go up 1, 2, 3 over 1, up 1, 2, 3 over 1. Okay, and again, I made 3 dots just to make a nice straighter line. And if you'll notice, these crossed, okay? They should be crossing at a really nice point, okay? We're not gonna get into like ugly things in between until later, but right now they should be crossing at a really nice point. So if you find the point of intersection, these both went through this point, so that's called the solution to this, and that point is over 2 and up 1, 2, 3, 4, so the solution is 2, 4. Okay, you guys have homework on this. You're going to be doing some like this where you're plugging them in to see if they work, and then some like this where you have to graph both and tell me the point of intersection.